So the past we wanted to honor because we had Sherry and Ralph and Jim, who I think everybody knows were really three giants in the field who really made a big impact and truly changed our world. And so Don is going to start out talking about Sherry and Ralph, and then I will take over and say a little bit about Jim. So Don, if you would come up and take over here.
Okay, so these are the people that we are honoring in terms of the retrospective. And, for me, it's a particularly happy day, not just because we are showing new growth within AirUCI and UCI in general, but also acknowledging the work that Sherry and Mario did many years ago. Barbara, my assistant, Barbara Chisholm, where are you, Barbara? Stand up. Stand up. Stand up. Come on. Barb sent out like a spam email to everybody saying, look, you know, this is going on, and to former group members and asking them to. And so just sort of as a show of power, I would like all Roland Group members to stand up, please. And that means the SARP students, too. So all students, yes. So these folks have come anywhere from the East Coast. You know, I came from University Hills, don't be too impressed with me. Okay, so it's a happy day, and I think the fact that we have these people who did come back and in some cases traveled long distances is an example of sort of the group that Sherry nurtured. Sherry was a bit of a hands-off guy, but he was always there to talk. And I, for one, having worked with him for 34 years, missed that interaction tremendously. Anyway, so my job is to sort of talk about these two folks for 10, 15, 20 minutes. So Sherry, as Enrique mentioned, Sherry came in '64, somewhere in there. He came to nothing. There were no buildings. There was nothing. And so for those who have worked in Roland Hall, I believe this is Roland Hall right here. And so this is what Sherry had to work with. So imagine being a professor. He had been a professor at the University of Kansas. He was a radiochemist, okay? No atmospheric chemistry, a radiochemist. And he came, and so in the basement of Roland Hall, we have a reactor. And the nuclear reactor is there because Sherry needed one for his research. So this is sort of what Sherry went through. And so for the first 5 years, until 1970, he was the chair. Hired 5 people besides himself, or maybe there were 6 founding members that he got within the first year, which, if any of you have ever been the chair of a department, that is an incredible hire. So this is what he inherited. I mean, look at how different. This is Campus Drive right there, I think. Anyway, so that's what he got. Now, so Enrique mentioned that Sherry went to a meeting, and this is a sort of some insight into Sherry's brilliance, is that he was a radiochemist. He had an opportunity to go to a meeting, I believe it was in Florida, and listen to some research that he was not familiar with. And these are his notes. He took incredible notes. And what he saw was in Jim Lovelock built an electron capture detector. He put it on a boat. It went from England to Paraguay and back, sort of a north-south transect. And what they noticed was that there was more CFC-11 and carbon-tet in the northern hemisphere than there was in the southern hemisphere. Sherry came back from this meeting. Mario Molina had just joined his group from Pimentel's group at Berkeley as a postdoc. And he said, you can work on this, or this. And Mario, being the smart guy he is, said, I'll work on this. And the good news is he was a photochemist. So he went into the lab, because the question is that are these things really inert? That's how they were being sold, okay, and marketed. These are inert. And so it turns out they were inert, except when Mario did some photochemical experiments. He put some CFC-12 in a cell, shined certain radiation of wavelength through this, and nothing happened. 100% of what went in came out. Cranked up the energy a little bit, same thing, same thing. And it wasn't until he got to a radiation of less than 220 nanometers that 100% of what went in didn't come out. Some of it was absorbed. And so this is, good sound photochemistry. He went to Sherry's office and they talked about it. I was not here. I got here in '78. So this was 4 years before I showed up. So, there was no internet back then. Mail took weeks. I'm not kidding. I tried to come up with an orals project. Sherry in Germany, me here. So he finally says, Don, just talk to Mario. Okay, because Mario Molina was a professor here. And so I talked to Mario. He's the one that guided me on coming up with an orals topic because the 2 weeks to no FedEx. Anyway, it's a different world, folks. Yes. So what happened is that two guys, Ralph Cicerone, an electrical engineer, and Rich Stolarski, came up with this stratospheric ozone depletion cycle. They did this in Michigan. Okay. Ozone plus chlorine makes ClO plus O2. A ClO hitting an oxygen atom freed the chlorine, and now the problem was that chlorine can jump right back there and kill more ozone. So Ralph and Rich did this. About the same time, Roland Molina, this was the experiment that Mario had done. Okay, and notice that when you photolize this, CFC11 or CFC12, look what comes out. So then Sherry and Mario on their own said, well, geez, I wonder what happens. The only place, folks, the only place where this kind of radiation that could break this up was available was in the stratosphere. So what's in the stratosphere? Ozone. Okay, and so Sherry and Mario came up with the same conclusions, same reaction, same everything. It's just that Sherry and Mario proposed a mechanism to get chlorine from down here up. And that led to the 1995 Nobel for Sherry, Mario, and Paul Crutzen got that also. So this is just memory lane, a very young Mario, a young Sherry, but a younger Mario, in Sherry's office. So Sherry had been a radiochemist. He then, in '73, '74, jumps into some photochemistry and atmospheric chemistry. And then we sort of diverged. Our group ended up doing some atmospheric chemistry. And so this is a flight that some people in this room were on. In Japan, Ed Mayer was Sherry's first atmospheric graduate student. Ty Smith and Sherry were on the airplane, the DC-8, in Japan. And Sherry was like a little kid on that flight. I mean, it was the most amazing thing to see this grown man. It was like he was at Disneyland. It was great fun. So then, October 11th, 1995, this is probably about 10:30 in the morning. Okay, Sherry gets the Nobel. He's notified that day. The school puts together this thing in room 308 or 305 in Rowland Hall. It's Physical Sciences Hall at the time. And so I'm not sure who took the picture, but looking at it, Barbara is looking at me like I just said something completely stupid. Joanne is probably, this is Sherry's wife, she's probably agreeing with Barb. Don, how could you say something that stupid? But I could not get this grin off my face for the whole day because of the Nobel. And there are people in this room who were there that day. It was a marvelous day. So then we move 2 months later. This is December 10th. So we had to wear tails and all, and Ralph and I and our spouses were 4 of Sherry's 10 guests that he could bring. So this was at 3 o'clock. This was at about 6 o'clock when Sherry got the Nobel. And then this was the dinner. And 1,300 people. Sherry is right there. My wife is right here. I was at the very end of the table. I was at the very, very end. Ralph Cicerone was 2 people closer to Sherry than me. And afterwards, I said something to Sherry about, I was so far away, and he says, Don, it was all based on table manners. True story, and probably true. So I just, some of you know Stan Tyler, some of you don't, but Stan was actually an undergraduate here in '71, and he did undergraduate research with Sherry. So he was actually an undergraduate with Sherry during the ozone stuff. And then he went on to get his PhD with Sherry. And Stan is a professor at Norco Community College, and he's teaching 3 or 4 classes today, so he can't be here. But I thought it was important to see how a former graduate student, one of Sherry's undergrads and graduates, felt about Sherry. And I think this is the most, and Dr. Rowland was a nice guy, which is not always the case when people are brilliant. And I think a lot of you who have maybe worked with some brilliant people would say that is not too far off. Okay, now, perfect timing. So now back to Ralph. Okay. So Ralph and Rich did this. So early on, Ralph was involved in this stratospheric ozone depletion work. This is a picture in '82. So these 3 guys are the Nobel laureates. And here's Ralph. Look at that look. Ralph worked a lot with Ray Weiss here, okay? And I think Ray would admit, Ralph had a playful side to him. I mean, I think that's borne out in this picture. And he was an incredible scientist, obviously in 1982. So 8 years after this whole ozone thing, he's at some meeting that's, the who's who of stratospheric ozone. So he did the chlorine work. This is a paper that meant a lot to me because I did methane. Methane was what I did my thesis on. And this paper by Ralph Cicerone and Ron Ormond, in biogeochemical cycles, I thought was one of the most important papers on methane ever. Okay, I have a few papers on methane, and I don't think any of them are as important as this one. And so Ron Ormond and Ralph did some really, really important, on methane now, not on chlorine stuff, but on methane. And this is a picture of Ralph that was sent to me shortly before he came to Irvine as a professor. He looked sort of carefree there. Then he came here and inherited ESS and did a great job, but starting a new department is non-trivial. And this is what he did. These are his founding members: Ellen Druffel, Michael Prather, Bill Rieberg, Sue Trumbore, and Darren Toohey. Darren sent me this photo. So that's what Ralph did, similar to what Sherry did in terms of hiring people and a tremendous group of people, I will say. So what did Ralph inherit? I showed you the picture of UCI when Sherry started. This is what Ralph was actually able to convince somebody to donate $6 million or some large number of dollars to build Crowell Hall. Okay, so this is Crowell Hall looking at it while it was being built from Rowland Hall. That's what it looks like now. Okay, and so a huge success early on for Ralph in terms of getting funding to build this. And then this is a picture, I don't know, this picture, these are the sort of 3 of several, but giants here at UCI. I don't know what the function was. And once again, I think Ralph got a little bit of a cheeky smile there. Once again, he was a fun, wonderful man. This is Francisco Ayala, in case you don't know. He's got the School of Biological Sciences is named after him. As an afterthought. Okay, so this is Ralph then more recently. And now, so going back to Ray's work, so back in the 90s, early 90s, methyl bromide was a very important molecule used in strawberry fumigation stuff. And while Ray was a lot more involved and instrumental in that type of research than I was, we did go to a lot of meetings together. And he and Ralph really sort of pushed this, that if we could regulate methyl bromide, we could have a more positive and quicker impact on stratospheric ozone depletion. And so Ralph's work, so first it was chlorine and ozone, then it was methane, and then he removes a hydrogen and adds a bromine, and he does methyl-bromide. Here, Ron Ormond, the guy that wrote the important methane paper, had such admiration for Ralph, okay, that here's Ron's name right there. They named a bacteria after him. Aminobacteria Bacter Cicerone, okay? So Ralph has a bacteria that I guess fixes, I mean, Ray can explain this to you later, methyl bromide. So he's got, so here is Ralph, ESS founding chair, Dean of Physical Sciences, Chancellor at UCI, and National Academy president. Okay, the National Academy is the most powerful scientific organization in the world. And he's got a bacteria named after him. And there's more. He's got a baseball field named after him. Ralph loved baseball. And so Ralph was a smiling man the day that Cicerone Field was dedicated. So he had, once again, he was a giant, a huge giant, and his passing was and is a huge loss. And my last slide, if it works, is a short video. Okay? For those who knew Ralph, and there are many of you in here who did, this will make you a little nostalgic. For those of you who didn't, I want you to pay attention to how he listens to a question and how he answers a question. Okay? He chose his words judiciously and rarely had to say, I didn't mean that. Okay? I say that all the time. But Ralph, I could take some lessons from Ralph. Okay, so now.
Okay. All right, let's just take this issue then in terms of science. Okay. Scientists, are they doing their job to get out there and report it? And what should they be saying about climate change? And is there a debate? Is this a thing in which there's only one side?
There's really not too much debate.
Yeah.
There's been a lot more debate in the media about how society should respond. A lot of debate there, but much less debate in the scientific community. And this is interesting, because a scientist gains notoriety and fame, so to speak, by showing that other people are wrong. So there's a lot of scientists out there trying to find out what's wrong with our view of climate change. And yet, all the ideas that have been proposed have more or less failed. The mainline view of climate change is that we are now undergoing a planetary warming, that it is due to human activities almost entirely, although there's always a chance for some natural warming, and that it's growing. And that human activities, mostly the burning of fossil fuels, coal, oil, gas, and wood, are causing it. So how big does it get, and how rapidly does it change in the future? How much will sea level come up? Will there be more intense storms? And how rapidly will the temperatures rise? These are the questions that depend on our ability to predict, but also on future human numbers and future human technologies.
So once again, for those, Ray's shaking his head going, you know, that's like having a lunch with Ralph. And the very thoughtfulness that Ralph had. And so once again, he is a role model for all of us, was a wonderful person, a wonderful scientist, and I'm honored to have been able to talk about him for the last 10 minutes. So with that, I'll turn it over. Now, hold on. Okay, so, I'll turn it over to Barb, who's won a lot of awards. But Barb thanked Melissa. She should have. She thanked several others. But anybody who has been on a committee with Barb knows that Barb does like 90% of the work. Okay? I love being on committees with Barb. Because I get credit for stuff that I don't even have to do. And so, Barb, you are the one who wrote the HIH proposal. You're the one that had this idea. And so while we're talking about the past, we got the present being these 5 new hires, Barb really is the driver of the presence. So I'd like to acknowledge that.
Thank you, Don. Very sweet of you. Thank you. Thank you, Don. He went off script. He tends to do that.
What script?
All right. So I'm going to finish up with the third of the giants we're going to recognize today, Jim Pitts, my late husband. Just to trace some of his background, he actually started at UCLA with Francis Blasé doing undergraduate research. And then he talks about the day that Pearl Harbor was bombed, and he said, you know, his mother came in and told him, he said, I knew the world would not be the same. And it turns out that Francis Blasé and a lot of the photochemists joined the war effort, and in particular, civilian chemical warfare, because they were chemists. So, Jim was in Panama for a couple of years, took a break partway through his undergraduate career, and they were developing masks to take out any chemical warfare agents that they thought might be thrown at them. So they had this mechanical goat that they used, or a real goat rather, and then they had a mechanical one, so they put gas masks on them and then put them out there and tried to see how many survived at the end. So he made, you know, talked about how hot it was and how many tons of charcoal he sieved for the masks and so on. So he made it sound like it was really hard. But then in his files, you find some pictures, like this one. You know, like the Happyland nightclub, you know, 1944. So here's Jim, and this is George Doyle, who was very serious, and he always called him Genius George Doyle. Then he came back and finished his undergraduate after the war and stayed and did his PhD. So this is Francis Blasé, they called the chief, and Jim, and then Jack Calvert, with whom he wrote the photochemistry book. So after he graduated in 1949, he went directly to a faculty position at Northwestern and was there from 1949 to 1954. And at that point, UCR was just starting, and he was asked to come back as a founding faculty member. And he said he was basically a native Californian. He actually was born in Salt Lake City, but came here at 6 months. So he said within experimental error, he was a native Californian, you know. And so this is the founding faculty, and so this is Jim here. And so he was there from 1954. He was the first chair of the chemistry department. So it's interesting to see the parallels between, you know, Sherry, first chair of chemistry here, Ralph, first chair of Earth System Science, and Jim, the first chair of chemistry at Riverside. He also co-founded the statewide Air Pollution Research Center. And this is what it looked like in the early 70s from the center looking north. This was not a big like fire burning or something. This was smog moving into Riverside. And so this is what he was confronting as a basic chemist, and reminded me of Bob Hope, who commented that he didn't trust air he couldn't chew, you know, having grown up in Southern California. So, so Jim, when he came to UCI, really loved interacting with people here, and the colleagues and the students. So he was a very important part of the first AirUCI group here that's shown here. This is Tracy Caldwell, our astronaut student. Interacted a lot with Don, and particularly enjoyed Don's son, Tim. And then he spent a lot of time with Sergey, and really enjoyed talking to Sergey about photochemistry and then some indoor air pollution problems. We had a summer teacher program for many years where we would bring in 20 teachers, high school teachers, for a couple of weeks. And Jim was a very enthusiastic participant in outreach to the teachers as well. So I think at the Gordon Conference about a year and a half ago, Paul Shepson chaired it, and he arranged a session in Jim's honor. And he started out by saying, you know, let's look at the list of topics that are being talked about at this Gordon Conference. And basically, let me go back and show you who was there first. And Jim had just a lot of scientific firsts. So he built this state-of-the-art environmental chamber at UCR, courtesy of California Air Resources Board support, and it was the premier chamber for many years. He teamed with the Germans to use the DOAS technique to measure things like the nitrate radical in HONO that couldn't be done easily before. So this was the light beam going across the campus to do long path measurements. And this was when Star Wars first came out. And he said there were all kinds of panic calls from students saying, what's going on? What's going on? He said, it's not Star Wars, it was Smog Wars. And it's interesting, the Germans had developed a DOAS technique, but when they tried to do some of these measurements, it just wasn't polluted enough in Germany. And so teaming up with Jim at Riverside really produced some great science. He actually did one of the first aircraft campaigns in California back in 1971. And they mapped out, for example, nitrogen dioxide concentrations coming from the Moss Landing power plant. You see that some of these are you know, above 50 ppm at higher levels. So he was a member of a National Academy Committee in 1972 on polycyclic aromatic hydrocarbons. And those of you who know Jim knew he was not shy about expressing his opinions. And when he believed in something, he would push it and push it and push it until he saw what he thought was the right outcome happen. So he was on this, and he actually got very frustrated because at that time, people really didn't think about polycyclic aromatic hydrocarbons and reactions in the atmosphere and what that meant for health effects. And so, so he actually ultimately refused to sign this report because he believed that it underplayed the impacts of polycyclics and the reactions in air. And that really inspired him to go and study this field. And so his group was the first really to look at mutagenicity of particles in air and show that the chemical reactions of polycyclics did increase the mutagenicity. So this was air, I think, from Pomona, and it was the Ames salmonella assay. So this was with nothing on there, and this were increasing amounts of particles that have been collected in air, showing that you get increased mutagenicity. He was in indoor air pollution back in the late 70s, early 80s, and so they actually set up a DOAS in an indoor trailer and measured all kinds of things like HONO and formaldehyde and so on coming out of stoves and out of paneling. And then he got interested in this. Sharper Image was saying, we're going to clean up your air. Just buy one of our indoor air purifiers. And so they had this great line. It was a free gift. And they said that this reduces the unpleasant odors by silently emitting safe amounts of ozone, odor-neutralizing ozone without any cover-up or fragrances. Of course, what it's doing, it's deadening your sense of smell. Right? So that's how it takes care of things and forms all kinds of other things in the meantime. So Sergey, for example, did some really nice work measuring how much ozone comes out of these things, and it was really, really quite astonishing. In fact, Jim and I went down to Sharper Image to check these things out, and we were going around going, I was afraid they might call security, right? There's some strange people here. He did a lot of work on amines in air back in the 70s and 80s. And this is a big deal now because of particle formation. We know that these play a major role. One particularly harebrained proposal that was made was to add diethylhydroxylamine to our air to clean up the air and damp the ozone. And this, was pretty astonishing. But of course, we're still hearing the same thing at times today, right? You're going to add something and clean something else up, and I don't think there's a good track record on that whole thing. And so it had been proposed to add this, and it turns out, so Jim's group got interested, and what they actually showed is that when you did it under atmospheric concentrations, you not only didn't quench ozone, you actually increase the rate of formation of ozone, peroxy, acetyl nitrate, and light scattering particles, and in addition, you formed mutagens. So, so again, he was there first. So he wrote 4 books, 380 pubs. He was a highly cited researcher. It's interesting, there was a symposium in his honor for his 80th birthday, and Sherry and Ralph spoke at it. And Lisa found the tapes from that. It was very interesting to listen to. And Sherry talked about the fact that this book with Jack Calvert, Photochemistry, is what he considered to be the beginning of atmospheric chemistry back in the late 60s. And then he went on to write a few other books with somebody else here. So I think that what Jim took the greatest pride in was taking his science and translating it into policy and things that would protect the public health. And he was particularly keen on NOx control. And Mary will remember many of these arguments back in the 70s, 80s, and they have continued up until recently that more NOx is good for you. And, you know, the chemistry can be complicated, but he really strongly believed that NOx control was essential for controlling ozone. I was on a National Academy committee back in 1991, and it was funded by Auto Oil, and the first question that was posed was, why are we doing all these controls and it's not having an impact? I'm in California, I'm saying you've got to be joking. You know, our air is cleaned up tremendously. And then I realized as the discussions went on, it was because California had controlled NOx, along with VOC, much more than the feds. And that's what's really helped clean up our air largely. And so Jim was very keen on NOx control. And you'll see, you know, this was 1975, 1993, he was still pushing on NOx and control of NOx. His group also developed the OH reactivity scale. So back in 1970 or so, tailpipe emissions, for example, were regulated based on the number of grams per mile that were coming out of the tailpipe, and it didn't matter whether it was methane, which wasn't very reactive, or something highly reactive like butene. And so his group developed the OH reactivity scale, and that was really the first beginnings of the control strategies that are now used not only in California but federally, that say you can emit a lot of methane out of the tailpipe because it doesn't react on the time scale. Of course, we're worried about climate change now, but methane. But you can emit a lot more methane than you can, say, of something that's highly reactive. So what matters is what's the reactivity that's coming out, not just the number of grams. So he also was very dedicated to working with politicians and policymakers to make sure the science was really communicated and what the science said about implications for policy and control strategies. So this was Ronald Reagan, and you can see he's showing him a lung here that has a little damage. Ed Muskie was running for president in 1972, and so was George McGovern, and everybody had to come by, and Jim would talk to them about air pollution. I actually have a really soft spot in my heart for him because my PhD orals were that day. And when I heard he was coming, I thought, oh no, I'm going to have to change them. No, no, no. It meant they could only grill me for 2 hours. And then they had to go see George. He's been one of my favorites ever since. And Jerry Brown, back in the 70s, he worked with. And for his 90th birthday, he got a very nice letter from Governor Brown saying, "You have played a seminal role in California's world-leading efforts to fight air pollution and form much of the basis of our current efforts to understand chemistry of air pollution. As director of SAPRAC at UC Riverside, you personally explained to me," and I can imagine he did, "the role that oxides of nitrogen played in smog formation. Thanks to the science you developed, California prevailed on this important issue despite opposition from the auto industry. Your research has directly led to measures taken by the California Air Resources Board during his first and second terms as governor of California, and has since continued to reduce the emissions of smog-forming compounds from vehicles and other sources. So more than 3 decades later, we've cleaned up our cars and made admirable progress in cleaning up our air and our skies." And a very nice note here that I very much enjoyed working with you many years ago. Like Sherry, he has really left a legacy of people working in this field. This was his 80th birthday, and you can see a number of the people that he trained: Janet Airy, Roger Atkinson, Tim Wallington, Ernie, Hajime Akamoto, who has really translated a lot of this to Japan. And then this was an interesting one. So Dick Schrock won the Nobel Prize in 2005. And he worked with Jim as an undergraduate at Riverside. This was one of his first papers. And you know, I kind of had that in the back of my mind when I saw who won the Nobel Prize. I said, "Didn't Dick Schrock work with you?" He said, "Yeah." So he immediately sent him a note saying, "At least I didn't screw you up." He has supported the next generation by setting up a scholarship. So these are the first 3 winners of the Pitts Undergraduate Scholarship. When I put this together, I realized I think I'm really in trouble. Look at this. I'm taller than her. I'm a little shorter than him. I'm really shorter than him. So I don't know if I'm shrinking or what, you know. A little worrisome. So he won a lot of awards, a lot of ACS awards, for example, the Service Through Chemistry, the California Lung Association, the Tolman Medal, Fellow of AAAS. I think the awards he took the most pride in were the ones that really recognized what he had done for translating science into public policy and public good. So this was the Haagen-Smit Award. in 2002. So this is Mary and Jim and a lot of other people recognize, Alan Lloyd and John Holmes and John White. So right back to back with this, when I found it, there was this slide. And I think he's worshiping at the shrine of Mary Nichols, as far as I can tell. And so Mary also sent a very nice note on his 90th saying, "You were a generous tutor to me and many other policymakers trying to devise effective strategies to bring back blue skies to Southern California. Equally important, you've always used your knowledge and connections over the years to advance the public good." That was a very, very nice note, which he appreciated. So for me, he was a collaborator, co-author, mentor, spouse, fly fishing buddy. And people wondered, you know, how do you spend all that time together and still survive? And there's a little key to this whole thing I have to share with you. And you, Professor Mulligan, promised to love, honor, and co-author at least 4 papers a year. So I'd like to finish up briefly with something that was characteristic of Jim and Sherry and Ralph. And that is the support of diversity in science, and particularly gender diversity, which I and a number of people in this audience have benefited from. So this was the Gordon Research Conference in 1969. And if you go through and look, you'll find there were 81 people and 0 women, 0% women. 1973, Jim was chair of the conference, and there were 90 people, 3 women, 3% women. And so being scientists, so that's me there, and so the increase from 1969 to 1973, since we're scientists, we've got to do this quantitatively, it was 3 divided by 0. So I would argue that Jim increased the representation of women by an infinite amount. This is 2015, and Paul chaired this one, and there were 175 people, 65 women, so it was a 30%, 37%, that's a 12-fold increase from 1973. And you will be hearing shortly from some of our student teams here at UCI, and at this symposium, out of 22 speakers, you will hear 14 are women, 64%. Now, yes, let's hear it. Now, I thought over the years, you know, why did this happen? Because there are a lot of areas of science and chemistry this has not been the case. And you stop and think, why is it in atmospheric chemistry that this has happened? And I really think it's because of the senior male leaders in the field, like Sherry and Ralph and Jim, who welcomed us, they supported us, they mentored us, and they didn't tell us we were any different or we shouldn't be doing anything but our best science and contributing. And so I really think we owe all 3 of these folks, you know, a big thank you for what they have done by their examples. And they never said anything overtly, they just did it and supported us. So it's very much appreciated. So with that, I will finish up, and thank you very much for your attention.